We're on the road.
We're on the road, mate.
Yeah.
First doco for the year.
Automotive doco.
Didn't have to travel too far, just down the road.
No, true. I was going to say we're a road trip, but it's been a short one. We're at Yatala.
Yatala, home of PWR.
Stone Brothers Racing.
Yeah.
Dick Johnson Racing's just down the road.
Just down the road.
Yeah, it's a little hub around here, isn't it?
It is.
The Yatala area.
Motorsport hub.
Tony Quinn had VIP Pet Foods down the road.
Yeah.
So we're in this little industrial hub of the Gold Coast at PWR. So advanced cooling technology.
Yeah.
Coolers, radiators.
Radiators. I reckon you would have wrecked a few radiators in your time, wouldn't you?
Mate, I think I got a pile about this high broken front radiators.
Doing some enforcing.
Get in there, mate. Get in there. Yes, really cool. I've been really looking forward to this ever since we spoke about it. To come and see Kees Will, who's the CEO of PWR Performance Products, and see what this company's all about. And mate, this is really exciting. This is a true Aussie success story.
Very cool. Isn't it?
So we're going to have a look through this entire factory, and it is massive. It's going to take a little bit of a time, but first we're going to do a bit of a review.
Bit of a review. Let's get into that, eh?
Bit of a motorsport review. Kees has organised us a little room to do a show. So the show's on the road.
Let's get into it.
Right.
You should have looked after us here, Russ.
This is very nice, isn't it?
Yeah.
Well, Kees Will has looked after us.
This is his media room.
It is.
So we must be media.
Well, yeah. Again, we're official media. No, it's very nice. It's their media room, and obviously with all their products, they come up here and photograph all their different things that they make and components that PWR manufacture and engineer. So yeah, he's lent us this, but this is a concept I wanted to do, dude, with when we go on the road and do the show. They'll actually do the show from here, review, and also a tour of the automotive facility.
Good
idea,
as well. Russ. You're an ideas man again.
Well, there's plenty of cool businesses around in Australia. People forget that. People forget in Australia we've got cool industries with very smart people that make cool stuff. And that's what we're going to show.
These guys are technology focused and employing a lot of Australians, and what I like about it is their roots are in motor racing, and it's what made them a successful company. So it's going to be good to take the tour.
Next level. This is next level.
Yeah.
But let's start the show with, like we always do, like we do at Norwell, bit of a review of motor racing. Jesus, been plenty going on.
I know.
Overseas at the moment.
I didn't get any sleep on Sunday night. I punched right through 12 hours straight.
I've seen you crashed out on the couch in an Instagram post going, oh, you just had an all-night bender on motorsport.
Moto GP, and then IndyCar, then NASCAR, all the way to, I think that finished about 12 o'clock on Monday afternoon. So it was good if you're into motor racing, and lots of Aussie representation.
Let's get on to the first one, and we haven't spoken much about him on the show because I've been waiting for the Indy to see how he goes, because we all had high hopes, had a few little dramas, otherwise for sure he was looking like a top 5 contender. Scott McLaughlin, I'll tell you dude, I've been so impressed with Scott, his ability to adapt. I was a little bit of a skeptic, I've got to tell you, and I'll be totally honest about that. I've been a little bit of a skeptic how it'd go, going from a tin top to an open wheeler, and especially an open wheeler in America, where it is a very unique series with both road courses and ovals, and ovals especially, how hard they are. Man, he's just been just straight on it. I mean, I suppose he's already finished second on an oval, which is unheard of.
It is, and I speaking from experience, I went and did the Indy Lights in 1998, and I actually found the ovals easier.
Really?
Because I didn't have any preconception of what the car was meant to feel like and what it was want to do, so I was really in the engineer's hands. And I think that's why he's been good on the ovals, because he's just going on what the engineers say. He's got no preconceived idea what the car can feel like, and he drives it to the grip level, which he's very good at driving on the edge of the tyre. So I reckon that's why he's been good on the ovals. And his test is how good he's been between his teammates, and he's been right there with some great guys, hasn't he?
For sure.
Will Power and Newgarden, so
he's
fantastic.
Had Rick Mears in his corner, which has been coaching him. And Rick Mears, an accomplished racer, especially on ovals. Rick Mears has been on the radio and coaching the ovals as well. That's obviously been a big benefit.
Yeah, Rick Mears stopped driving for Penske, but stayed on as the team driver coach. And you look at all the success they've had with their drivers. Rick Mears has been a really good part of coaching and mentoring all their drivers right through. And if you look at even who the winner was in Helio Castroneves, he's a Penske driver that let go. And then he goes to another team and gives them a dust up. And there was more Penske people congratulating him for the win than there was his own team. It was pretty good.
So I'm going to keep pumping Scott's tyres up as well because mate, when you start looking back at some of the cars he's driven here, like in the Volvos and that sort of thing, and everyone, I remember people say, oh, those Volvos have got strong engines and the chassis are better and the smaller. There was so much Scott McLaughlin factor in that, and that's not taking away anything from the preparation of those cars and the team that ran it, but I think there was so much of him. That was an early indicator on how good he actually was, and I think we're really seeing it now because, like I said, to go, like I've seen open wheeler drivers reverse engineer and come to touring cars and been good. I haven't seen too many go the other way, at all, if any. Yep. So he's really stepped up to the challenge, and it shows you the talent of the guy. Like I said, I'm super impressed, and it was a shame the way it happened, but I think he's definitely shown enough already.
The small mistake on pit lane, yeah. So, but that wasn't uncommon. If you look at Will Power had the same problem.
Yep.
Simona had the same problem. Both Penske cars. So there's a few guys. So something going on there with the brakes where they're trying to get the pads away from the rotors and maintain speed.
That's a good point.
I think they've got something there in the braking system. They just haven't got the pedal up enough, and there was too many people to have that same problem but not be car related. Scott was the only one that come out and said, I didn't pump the pedal up. Will Power and a few other people just said I had no brakes. So
we're straight down.
Straight down, which it's a similar situation where we've all seen it at Bathurst, where you've driven out of the pits and lobbed the thing at turn 2. Mm-hmm. I think they've been on the oval. The pads are knocked back and they haven't got them seated on the rotor properly and just arrived a bit too fast at pit lane. But if he didn't have that mistake, he could have been anywhere between 1st and 8th position. So
sure,
pretty strong running.
So for anyone that has watched in-car camera in a supercar or any sort of motor racing where they see him tap the brake, that's they're pushing the pads back to the disc, and if you don't do that, they gradually come out. When you go to hit the brake pedal goes all the way to the floor because it's taking up that distance back again.
That's
so
it.
That looks like, and you're dead on the money what's been happening, because the engineers want those pads away because of course drag anything, especially on an oval.
When I was over there, on the ovals, we'd lock wire the pads back for qualifying, so they wouldn't rub on the disc. And if you're in an emergency situation, you could still get the brake and break the wire and get to the thing.
That's a bit.
But that's what they're going to.
That's a bit iffy. Yeah.
Any sort of friction losses in those ovals, it means a lot.
Yeah. So a great race. Helio Castroneves. But I mean, 46. Seriously, like how good's that? One for the Grey Army.
Just proves, Russ. Just proves that He thought that race out. Obviously, he'd done it a lot before, but he played those 3 guys he was racing with pretty good. Went to the lead when he needed to. Used the traffic to maintain his position at the end, which was pretty smart.
Smart racing.
Smart racer. Got the trophy 4 times, even though Paul Tracy reckons that the second one was his. So
bit of controversy, but that's always good. But
it's good.
Yeah. No, it's good. It was a great event. I mean, you look at the crowd numbers and it's just insane. Fantastic event. I've never done it. Got to be on the bucket list one day to do that.
150,000 people at the circuit. There's still COVID rocking around America, and not many people wearing face masks. Looks like that country's just gotten on with going racing and getting back to normal. So it's good to see. When
it comes to Indy, not even COVID can stop it.
No.
Unbelievable. Moto GP, Remy Gardner, first win for the year. Championship lead. Smart racing, just smart. He's just over the last couple of seasons, or this season in particular, just thinking about the racing and the way he timed that.
He seems to have a real good feel for the tyre, doesn't he? He let his teammate go and then just sat there and waited, and then just at the last lap, like 3 corners from the end.
Yeah, I know.
And then had enough tyre to stay onto it. So
Let me ask you something though.
Yeah.
Did you notice his teammate when he was following? I thought he'd get him under brakes going into turn 1, but they just kept pulling away. It looked like his teammate had 10 more horsepower.
Yeah, he's definitely got a straight line disadvantage Remy. He's a bigger guy, so he's heavier than the riders he's racing against.
Yep.
I think we've spoken about it before that if he gets on a Moto GP bike, which he should do, that he should get a KTM ride next year, it'll really suit him. He's a bigger guy, he can wrestle the thing around there, animals are bikes. So that's where he needs to be.
So that was a straight line difference.
You could see that.
Just because he was a bigger,
he couldn't tow, and then he got dragged off to the line. So yeah, it's pretty common what his issue is. He's just a little bit big for those bikes.
I was always wondering that because I look an old mate. He'd come on the straight and he'd just start. I'm going, yeah, okay, why is that? And then through all the twisty section, straight back onto him.
Yep.
Yeah, and I thought, I wonder if he's getting dudded engines, but that makes sense now. Bigger, taller guy, more wind resistance.
It just shows how like he was on a non-factory bike last year, pushing it and overriding the bike, falling off sometimes.
Yep.
Now he's on a bike that's capable of winning and showing he's thinking about what he's doing and piecing the championship together.
Yeah.
Really good to watch, pretty incredible.
Winton's got boned because of the lockdown in Melbourne.
Yeah.
Probably, harsh, but probably the right thing to do. Whatever
it was a tough one because Benalla Auto Club at Winton are the promoters of that race. They're telling everyone we've got a COVID plan, we're a rural event, and you had to have a 50 bet each way. Do you send staff and personnel into the eye of the storm, which you didn't want to do, but we sent people down there, but most people just sat on the border at Albury and waited. Like the Albury airport looked like the most busiest place in the world on Thursday morning, but I think we all knew it was going to come. And once Melbourne went into Victoria went to a statewide lockdown, we had to get out of there. So tough one. Common sense when you looked at all the things and the play, how the Victorian government had gone before was this thing can't go ahead. But yeah, we all went down there. So
just hope Darwin's going to be safe, right?
Yeah, so the thing there is now, if they can get those Victorian teams out of Victoria into New South Wales, they can self-isolate, not in quarantine. They can spend 14 days in New South Wales, show they're clear, the event will go on. So again, the Victorian teams have got to take one for the team. It's going to be hard on those people with families and the mechanics and all the people involved in those teams that are going to sit in New South Wales for 2 weeks. It's a tough one,
So this stage, Darwin's. You reckon Darwin's clear? It's going ahead. Okay.
I think stadium. If Supercars aren't there, the stadium trucks will be the key act.
I'll be there, mate. We'll be there.
We'll be there.
Yeah, I'll get another gig.
But to all those teams, the Victorian teams that have got to do the heavy lifting again, man, that's a big sacrifice.
Yep. I had a sneak peek of a Gen 3 chassis.
Oh, yeah.
I didn't want to talk about anything because we covered it in the last show, and we really wanted to smoke over it hard in the last episode, which we did, and we got good feedback. Thanks to everyone as well.
Was there any provision for a gear shift in there?
I didn't see one, mate. I didn't see one at all. No. But I can't talk about it because you're not allowed to talk about it.
Oh,
and the individual that gave me a look around couldn't talk about it. So again, we're in this cone of silence. The Gen 3 cone of silence.
Must have put some pressure on Supercars because they released a CAD drawing.
Oh, a cartoon drawing, yeah.
Yeah, the CAD drawing of the car.
Oh, so, yeah, okay.
So that, you just see that?
Yeah, I saw it, yeah. That filled in a lot of gaps.
Yeah.
Not.
So, yeah, you're right. You can't really talk about it because we know all we've seen is the steering wheel, the CAD drawing. We know what transmission's going to be in it and a couple of nice pictures of it. So
there's some things I've seen. Look, I had a good look over it and some of the components, and look, there's some things there which I reckon are viable. I've still got a big question mark about the cost. I sort of sat back and looked at it and went, doesn't look cheap. Could be wrong, I don't know. If I'm wrong, prove me wrong, guys. Come and tell me why. But at the moment, no one can say anything about it. So still in the dark. Anyway, that's all I want to talk about Gen 3.
Yeah, well,
I'm sick to death of it.
I don't know why they just don't show you what they got. And the reason they don't show you what they got because they don't have it.
Yeah, that's it. It'll just put it. I like information.
Yeah.
So and the difference is someone that we're about to meet, Keys Will, who's the CEO, founder of PWR, and we're about to meet him, see Keys' story, or listen to Keys' story, and show us around this magnificent facility. I'm really excited about this, and he's got engineering and contracts with big F1 teams and that, and he said he'll show us as much as he can and pretty well of it. So he's exactly the reverse. He said, look, there's a lot of very secretive things that go on, but you know what? We're going to show you. So how good's that? Here's the flip side of someone that's going to open their doors to everything.
That's good.
Very confidential. So I can't wait to have a look at this, guys. This is going to blow your mind. So let's go meet Keys.
Righto.
Come on, dude. And we'll get going.
Hey,
how are you, mate? How you going?
Hey, dude. How you going? How are you?
How are you, mate?
Good to
You
see
going
you.
all right?
Geez, you're looking well.
Oh, just trying to keep young. You know how it is.
Nose looking brilliant.
Yeah, just trying to keep up.
Hey, thanks for having us down here. I know you're a busy man nowadays. You've taken on this giant of a business. But tell me, how does someone that goes from working in a wrecking yard or owning a wrecking yard going to a copper mine in Bougainville?
Yeah, that's right.
Yeah, in Bougainville.
Yeah, there's a bit of a story there, isn't there?
Yeah, there's a few stories. I'm sure you've got plenty. And then end up with this giant of a manufacturing facility here at Yatala on the Gold Coast. It's been a wild ride.
It's been a wild ride, yeah. No, it's been good. I think like everything, you take life as it is and opportunities and what have you. I come to the coast here in '87. You know, prior to that I had wrecking yards and what have you, but coming to the coast in '87, we set up a small manufacturing plant down in Currumbin, and that ended up being fairly large. You were there.
I did.
I seen you there, and
I sent you an invoice for that too.
yeah,
I think.
Yeah, I think. Yeah. Oh, that's usual.
No. So yeah, I came down, and that's what.
Does this one cost me money, or?
No. This is
right.
This is FAC.
Oh,
this is good.
Goodness me.
But that's where I first met Keys.
We're trying to get a free radio.
No, I went down to do a Christmas function.
Yeah, with Castro. Yeah.
K&J. With K&J radiators.
Yeah.
And that's when I went down there, and that blew me away. I went down there. I thought, holy hell. Pretty impressive facility.
Yeah, no, it was good. And it was all copper and brass back then. And we put a aluminium furnace in '96-ish, thereabouts, 96, and started aluminium. Sort of a little bit ahead of time in Australia, because the only sort of cars that was the early Commodore that had a aluminium radiator in it then, and
As OEM.
Yeah, as OEM.
Yeah.
And Ford was still running the copper and brass at that stage, and so it was probably ahead of time. Like most things we do, we try to step ahead and see what's there. But so it sort of went from there, and then Paul was he was an apprentice machinist in the machine shop, and I said to him, I said, maybe we should be selling radios to V8 Supercars and what have you. And he said, no, nobody's going to buy from us, we sort of joked around, like he was 16, and I said, well, mate, the opportunity's there. And so that's sort of how that started. And so he went off to TAFE and learned how to weld and this, that, and what have you. And so then got to the stage where he had a couple of people working for him, still in my factory, and he'd go out in the morning and say, I want a radiator here and I want sheet metal there, and machine shop stuff for this, the fittings and what have you, and he'd stop back at night time and weld them up, and he was just going like that, pocketing the cash as you do back then. He's a kid, and sort of got to the stage I said, mate, you're gonna have to do something, as you register a small business and what have you. So that's how PWR was started.
Right. So PWR actually ran on the side of K&J radiators, and that's how it all got going, and that was
that's
with
how
Paul,
it started, yeah.
Obviously his son, and in between that you're running a race team and all the rest of it. So.
Yeah, all the fun stuff and what have you, and then we started building here, and when we built this place here, it was always going to be PWR, and and people were saying, well, what are you building this place for? And we just threw a comment, we're building this place with the right infrastructure to go after the rest of the world. And then when we finished this building, it was right in the middle of the GFC. And can you imagine what happened then? Spending a fortune on a place like this, it's flash and this, that, and what have you.
Moments,
And so that's when the real action happened. So that's when I went straight to NASCAR, and the year after I went to F1, et cetera, which we can talk about later on.
Oh, for sure. Now we want to have a bit of a look around. So Paul, You go prep the boys, do a bit of a recce, right? You do the recce.
Yep.
I'll grab keys.
Yep.
All right, and we're going to do a lap around this place because it's going to take us a while.
I'm going to find the good stuff to look at.
All right, you do that.
Okay.
Get yourself prepped and we'll get going. Yeah, it's awesome, Keith. Thanks for, I mean, I know there's a lot of sensitive, confidential projects going on here, because I know your involvement with Formula One, and that's one of the things that we'll touch as we're going around. But I certainly appreciate that you can open the doors to us.
Oh, for sure. And, you know, as you would know, and a lot of people out there would know that, you know, we sign NDAs with people, and all our staff sign NDAs as well. And so they know. But then, again, you can't sell a secret. And as I said to you this morning over coffee, we're just having a chat. You know, we're looking at stuff and say, you know, but people need to know some of this stuff. You know, some of this stuff is pretty cool. And so people do know. So anyway, we'll show you what we can and whatever. And I think people will get a pretty good idea of what's happening here in this building and a few other buildings that we've got next door to us.
I'm really looking forward to it. All right, let's hit the road. Let's go. Okay.
No
Cheers, buddy.
Okay.
Hey, Matthew.
Hey, Russ, how you doing? Good to see you.
How's the Chief Operating Officer of PWR going?
Mate, we're busy. We've got a lot going on.
It looks like it. Look, I've lost my mate, Paul.
Yeah, right.
He's off with keys. He's skulking around the back there, lining up some cool stuff for us.
Yep.
So I'm going to do the first part of the tour.
Yep.
This is the stuff I like. So, do you still call these CNCs? Because
absolutely. So
these things are enormous, and you've got a part here.
Yep. Part of a billet tank. It's one of our high-end assemblies. So a lot of our high-end assemblies require full billet tanks. So they've got integrated fittings and the likes, and high-strength alloys that can be produced from. So,
right. So we gesture you've got a lot of Formula One contracts here, and you do a lot of confidential stuff. So a lot of that gets made through here.
Yeah.
Now these are pretty special, because Keys was telling me that they're actually robotic.
Yep.
That most CNCs just make one component.
Yep.
This does multiple.
Yeah, that's right. So we've got a total of 25 CNC machines here at PWR, and we've got 5 more joining us at the end of the month.
Wow.
This is one of 6 fully palletised systems. And when I say palletised systems, they've got a huge tooling bank. Each of these machines holds 120 different tools.
Really?
And this particular machine has got 12 pallets attached to this machine and a robot loader in the centre, and that robot is automatically loading and unloading raw billet and finished machines. So these machines run 24 hours a day, 7 days a week, machining parts.
When you say pallet, show me when you say pallet.
So a pallet here is one of these steel fixtures that's got keyed points on the bottom that can be accurately located in the machine.
Yep.
We can have all of our fixtures already positioned on those pallets, and the robot in the centre is just grabbing the next job and feeding it into the machine. Then as soon as it's finished, it brings the part out, parks it, and then grabs the next bit of raw billet and loads it into the machine.
Is that right? So instead of just reloading the machine for one component, you can actually do multiple in the same program.
The beauty of this machine is its flexibility. We program off a common tooling library, and unlike conventional CNC machines that have maybe got a limited number of tools available to them, where you would set up and manufacture batches, this machine doesn't care which part it machines one after the next. So if you've got 10 fully bespoke individual items one after the other, it'll just produce one after the next. So it kits out your components and then it can go again.
Wow.
It's
So
really,
if you had
really flexible manufacturing.
So if you had an order for a Formula One team for one component that had 8 or 10 components to it, you do it all in that one batch.
All in that one batch.
Grab it all, comes out as a part here like this.
Yep.
And then assemble it all, and it's done.
And that's the way that we work with our customers, in the sense of almost like this just-in-time manufacturing. So rather than set up and manufacture large batches all complete before you need them, these machines allow us to kit the components virtually one at a time as we need to make them. And it also keeps us flexible with a customer base that constantly wants change.
especially with someone like Formula One who's probably constantly evolving and changing.
Correct.
A cooling system for whatever, whether it be for engine or oil that they had last meeting, they may want to change it for the next one, and you've got to do that in a hurry.
And this is a flexible manufacturing facility.
Dare I ask how much one of these machines are worth?
One of these machines, just the machine alone, before you even put tools or any fixtures in it, is over $1 million.
And how many of these you got?
We've got a total of 6. So.
And more coming.
And more coming.
fair investment on either side.
Investment.
This is very cool.
Yep.
All right. What's next on the magical mystery tour?
We'll take you into our specialty build area where we produce a lot of the highly complex heat exchangers.
Let's have a look. Sure. Now, Matthew, this is the one I'm looking forward to. This is a secret screw, the little skunk works. This is where it all happens. So this is Formula One, Moto GP.
Yeah, LMP, anything that requires what we would consider to be unconventional manufacturing processes to build intricate shapes, highly specialised heat exchangers.
All one off.
All one
off.
Absolutely.
So you do, or PWR do 9 out of the 10 Formula One teams.
That's correct.
And possibly the 10th.
And we're trying.
We're working
with them.
That's not a bad. That's not a bad hit rate.
It's not too bad.
As well as, like you said, Moto GP.
And Le Mans. If they were 56 cars on the grid, probably 50 something have PWR coolers.
Really?
So, yeah, absolutely.
I mean, it's a massive achievement.
Yeah.
Matthew, when you look at the scope of all of this,
Yep.
and the people that work here, the specialised equipment, I'm looking at what the hell is this about?
So, I mean, that's just an example of the sort of sculpting that we can do in terms of how to get the maximum amount of surface area into a tight space. I mean, because not only are we building heat exchangers, but we are building aerodynamic devices, and we are trying to benefit the car in other ways as well.
So what was this originally?
It's a water radiator. Yep. It's a Formula One water radiator.
Is that right?
Absolutely.
It looks like it goes over the backrest of a car.
You're pretty close. Yeah, you're pretty close.
Is that right?
Yeah, you're right.
I know you're not saying much. You're not giving me much.
Well, because of the nature of where we are here, I have to be careful about what we can say, and we certainly can't get in too close to some of the detail. But this is several years old, this particular design.
Okay.
But it's an indication of the types of things that PWR is capable of producing for highly bespoke.
So something like the Moto GP radiators, like that one there, which is a bit of an odd shape.
That's right. Yep.
And you touch on it just then. They're actually, I've seen some radiators here that actually look like they're twisted.
Correct.
It looks like someone's dropped it.
Exactly. Yeah. So we can do staggered. No,
that's about aerodynamics.
It's all about aerodynamics. That is correct.
So they're using the radiator for downforce in the car.
And it's also about getting the maximum amount of surface area in the tightest possible body space. So if you're able to either curve or twist the shape of that heat exchanger, it allows you to do different things with the external bodywork that benefits the car in other ways, but still
making it narrower.
Exactly.
For instance, that sort of thing. And so you're involved in that process as well, because obviously how their bodywork is designed is depending on what you can get.
It's a real collaboration between us and the teams in terms of us determining what is the appropriate construction of the heat exchanger and then fashioning it into a shape that fits their aerodynamic strategy.
So between the engineers from the Formula One MotoGP teams, along with all your engineers, they design the most efficient product. But tell me, how does it work when you're doing 9 out of the 10 teams? How do they trust that something you're building for a red team isn't the same as the blue team? There's a lot of trust goes on there, considering you're under the same roof.
Yeah, look, a massive amount of trust, and I would best describe that, and we've been able to manage that for 10 years plus. I would best describe that as it's our responsibility as an engineering group and as a manufacturer is to work with all of those customers to ensure that they understand what is possible, what PWR's capabilities are, and then empower them with the ability to make good decisions about how best to utilise our skills. You know, we've got to be careful that we don't lead someone to somebody else's solution, but you can share with them what is possible and then allow their engineers to then work with us.
It's a fine line.
Very fine line.
It's a fine line.
Absolutely.
That trust between the two, that's saying you're not giving away your secrets to someone else.
Agreed.
Man, that's pretty cool. But this is a blowout. Like this is, I can't believe this group of people here, all around here, are building products that are in some of the fastest, most technically advanced race cars in the world.
Absolutely.
Like it must amaze you every time you come to work and see this.
It does. Look, the opportunity to work in Formula One in the Gold Coast in Australia is unheard of.
It's just
outside of the walls of this building, doesn't happen.
It's just amazing. Well, I know Paul's waiting for us in the next shop. He's been skulking around, finding stuff for us to dig around. So be careful because he's a bit shifty, all right? So let's go check out, see what he's up to.
Yep.
Okay, Matthew, this looks expensive. What do we got here?
It is. It's our industrial CT scanning machine. So
Okay.
let's go and have a look.
Oh no, dude's already here. Dude,
My elbow's been playing up. My elbow's been playing up.
have you read the
I
sign?
know, mate. I thought I could come in and get my elbow done instead of having to go down the
There's radiation area, and you're just firing around in there. I'll leave you alone.
CT scanner.
I'll leave you alone for 10 minutes. What's this thing worth? And you're just jumping around like it's a jumping
The
castle.
same one as the hospital. Sure.
Yeah, you can't mess around with that either. Matthew, tell us about this rig. I mean, it looks incredible.
Yeah. So this is it's an industrial CT scanning.
Oh, okay. Maybe I can't get my scan.
Yeah. So basically, what this allows
Hang on. CT as in hospital.
As in, X-ray, so three-dimensional X-ray. So, so any of our components, we're able to do a CT scan, a full three-dimensional image, where in the instance of a welded assembly, we can check the integrity of every single weld and every assembly. We can check the braze quality, and also in the instance of additive manufacturing, which we can talk about later, we can actually interrogate the internals of additively manufactured parts, which means that you've got the ability to look inside of components that you would otherwise have no ability to be able to critique the internals.
Awesome. Yeah, that's amazing. So especially with welds and that sort of thing, to know something that's going in a Moto GP, you want to know it's not going to crack apart.
Yep, absolutely.
You don't get any better than that. That's better than crack testing.
It is way better than crack testing. It is a non-destructive testing tool, but it actually also can be used as a measuring tool, just like our coordinate measuring machines that traditionally would go point-to-point measurement. Because it creates a full three-dimensional model of the part, you can actually then take both the 3D data that's created of what you've scanned and overlay that over the model that you drew, and both on the external and internal surfaces, you can do a dimensional report regards any surface variations from what you've physically made to what you actually intended to make, down to microns.
So I'm Mr. Formula One team. I order my coolers.
Yep.
Do they come with a report from this machine?
CT
so I
scan.
unpack it, the scan's there.
Yep.
I know exactly what I've got.
It's got your dimensional reports, it's got maybe a flow test report, it's got a CT scanning report, everything that means it can just come straight out of the box and go straight onto the car, because the cost of failure is so substantial, and particularly now when they're working under cost caps and the likes, they need to make sure that every component that they take is going to meet the anticipated mileage that they've designed for.
So if they get a leak or something happens with it, but you go, oh, hang on.
You can understand.
Well, not only that, you've covered yourself, because if Fred Flog installers dropped it on the ground and went, oh, it should be all right, and stick it back in, hey, that's perfect.
Understood. We can see anything from mechanical damage that's occurred in use, or equally interrogate things that have happened on the car, whether it be through vibration, whether it be through impact. You can clearly identify if there is in fact an issue, rather than it's not just blame the manufacturer, which we're fortunate we don't get much of, but it's about understanding
There's the model up there. We should have it.
This is incredible.
Look at
Yes, we sure can. That's a scan of the existing part, and Miles will be able to walk you through just how close we've been able to.
It's just like being at the hospital.
Exactly. Yep.
Except you're doing parts, not pieces of your body.
Not knee joints.
So we've got three views here. This is our 3D model view that it generates. I can move that around, spin it around however I like.
Just like it was a model, but that's the actual scan data from the CT.
Yep. And this view is this plane here, you can see. 2D view, I can expand that out and zoom right in. I can see tiny little porosity. And I can slide through this just like so. And then this will be the top view. I can go through these welds, which is what I'm inspecting. And over here again, we've got another view there.
Internal.
Wow.
So you can section through that entire assembly just like you were modelling it, but rather than it be the model, you're seeing real-time information regards the material forms.
This is mind-blowing stuff.
Yeah.
Whoever would have thought for a radiator? But
Cooler.
like, it's pretty important. Yeah. Cooler. All right. Well, this just keeps getting better and better. You got anything better than this?
Let's go to additive
I
manufacturing.
found some bad stuff.
Have you? I knew you would when you're skulking around the joint. I knew you'd find something good. It looks very clean in here, Matthew.
Yeah, it needs to be. It needs to be temperature controlled, humidity controlled as well.
So it feels like a nice temperature in here.
Yeah, absolutely. So we've got two types of machines. We've got a more conventional additive machine, and then we've got our Velo. The Velo is sort of the jewel in the crown, and it's able to manufacture components at a complexity that conventional additive machines simply
So
can't do.
hang on. You're saying additive?
Yep.
3D printing.
3D printing.
3D printing.
3D
That's
printing,
a
so-
Hollywood term, is it?
Correct, it is. Additive,
Does
correct.
that mean
So-
because of ads?
That's exactly right.
Yeah,
So
okay,
rather than
yeah, I know.
subtractive. So subtractive is CNC machining, where you're taking it away, and additive is building it up.
So this is just like, plastic 3D printer, but
Using aluminium powder,
Powder.
and it's using a laser to solidify that powder layer by layer to construct components. So a few examples lay out. That's a little heat exchanger that's been stopped in process, but that gives you an indication, and feel free to go and
Hang
have a
on,
look.
this is alloy.
That's alloy, it's aluminium. You
I
can
thought
machine it.
3Ds
you can-
only did plastic. I didn't think this was technology was up to speed
No,
yet.
you can machine it, you can weld it, it's aluminium, and you can see the detailed features on the inside there.
No way. Yeah, have a look at this.
Additive manufactured 3D printed tank.
Are you kidding me?
we'll have these in our body soon. Spin
Yeah.
a new knee, bang, whack
Body
one
parts.
These are examples where you can see you can create a turning vane or something of that nature that would be otherwise really difficult to produce with a CNC machine.
That's just amazing. So this is...
These are test prints, so these are just pushing the parameters of the machine to be able to do more complex geometries and changing different parameters in the machine. So these are just test pieces to... Ultimately what we're trying to do is produce the thinnest, non-porous structures that can be additively manufactured. So of course it's important that one fluid can't pass across the structures that are being created.
Yeah.
So they need to be airtight, they need to be liquid tight.
All right, so this is a plate that goes in
This
the
is the
3D
plate
machine.
that sits in
so
the
that's
machine.
in there at the moment,
It's
making something?
It's currently operating. Yeah,
Wow.
it's actually producing something for one of our Formula One customers at the moment.
What's the biggest item you can make? How big physical size at the moment?
Yeah, we can produce in this particular machine. So
Yeah.
this is about 350 odd millimetres round,
Yeah.
and we can print up to about 400 millimetres high.
Wow, one component.
One component.
A single component.
Yep.
All from nothing.
Or
Nothing
just
is
from
this.
dust, aluminium dust. Yeah.
It's I can't get my head around it. But imagine trying to machine that.
Yeah.
Can't.
Yeah. The
That's
sort
just
of-
incredible.
Which is, now you can see the sort of detail that's inside of that. You can appreciate why the CT scanner is really important, because unlike conventional manufacturing processes where you've got the ability to inspect the various components before you turn them into an assembly,
Yeah.
with additive manufacture, you're literally creating the components from nothing,
Then I think, yeah.
and you need to be able to inspect the internals of those components before
What's the
they're
most
released.
intricate thing that you've done so far, Matthew? You done anything really complex?
Absolutely, yeah.
Yeah,
So
well, what can you show us?
multi-chambers.
Can't tell you, got to kill you.
Correct.
show us?
Can't show you.
All
and
right, okay.
unfortunately,
Must be pretty cool.
operate under very strict non-disclosure agreements. So Russ, unfortunately, I'm going to have to decline that one.
Okay, all right. No, that's good. No, we're going good so far. That's incredible. So that's it going there. And
That's the Velo machine. Yeah, correct. And we'd be able to see. You can see the outside screen here, where it's actually going to demonstrate what's actually happening inside those ports.
oh, okay. That's starting to go now.
That's the
It
whole
So
plate there, and it's whizzing around here and here, eh?
So that'll show it as it's starting to get built on that screen.
correct. Layer by layer, you'll see that part being being lasered.
Okay, I've got a question for you. Something like a component like this.
Yep.
How long would that take to do that machine?
that one component?
Yeah, look, a component like that would probably take something like 24 hours to print.
24 hours.
Yeah, probably
Plug it in in the morning.
But it'll
next day.
print, correct, you've got a finished tank.
Right. And as the machine technology gets going, that'll become quicker and quicker, obviously.
Yeah. Look, also, PWR is very specific in regards to its machine choices. Many additive machine manufacturers are trying to replace conventional technology like CNC machining, like casting and the likes. We made our choices for very different reasons. We actually made our choices about what machines could make the most complex components, rather than necessarily how fast can you make them.
Unique and one-off.
Correct.
More so.
Yep.
And probably looking for the future when electrification becomes more popular for cars, which I'm sure you're going to tell us about down the road.
Yeah. Look, additive manufacturing for us was about starting a journey to make sure that we understood the technology. And as you will have seen going around the factory, PWR is about making sure that it can solve any of those thermal problems by whatever is the most effective and efficient method. We manufacture it here at PWR.
In-house, keep ahead of the game.
Exactly.
All right, well, it got better. Is it better than this?
Take a look to our clean room manufacturing.
Clean room?
Yep.
You can go in, I probably can't. You're very clean.
Sorry, dude.
You gave me a tune up about the inside of my car this morning, so I might be going inside there.
Okay, so welcome to our special clean room assembly facilities here, where we make some very specialised compact heat exchangers.
Compact, like
compact
small
heat exchangers, so very, very small, intricate assemblies. It's operating in a medical grade clean room environment where each of the rooms are pressurised from the most intricate assembly process, and it slowly degrades through the system to make sure that the end process there is no trapped debris or contaminants or anything of that nature in the final component.
So, is that because the size of the tube, or the cooling is so small?
Correct,
A
it's correct. A bit of dust can actually fail apart. It's also the joining techniques that we have in actually bringing all of the components together. They need to be extremely clean and free from any contaminants.
Even though it's an automotive, or it can be an aerospace component,
aerospace and military
like
is also
but
another
is
application.
that critical to be that clean?
Yeah, absolutely. Yeah,
really?
For sure.
Even though it's going out in the field,
correct,
so to speak.
Yeah. So it's critical throughout the process of manufacture, and even in application, it needs to be operated in a highly filtered system.
Have a look, dude. Like it's just immaculate. Like everyone's in
it's
coats
like a surgery.
I think it's better than a surgery because no one's chopping you up.
I'd get work on here. It's just amazing.
I would.
So that's all. Hey, have a look.
Well, they look like they're working in medical.
Correct.
Exactly.
And so have a look at everything. So all the equipment they're using, the
It's
tools and everything.
Layout like they were
It's just-
going into surgery.
it
and
is. Have a look
you
at
see the staff are wearing protective gowns, gloves, as well as also masks, which is not COVID related. That's actually also just making sure that even the components are not being breathed on, because that can have a negative impact on the outcome of the assembly.
I'm just, I'll say it again, I'm just blown away because I keep thinking of radiators, you know. But have a look.
Well, they've got radiators. Still got them.
I suppose.
But
what are we talking here, Matthew, as far as, like when you talk aerospace, are we talking aerospace? Like up in there?
Absolutely. Look, everything from rockets to, we do a lot of work in electrification now as well. So not just in motorsport and automotive, but electrification of aerospace and mobility generally. So
really?
working with these electric vertical takeoff and lift manufacturers as well. So so people carrying drones or even autonomous drones. So.
And what are you actually cooling the electronics down?
Yes,
it's like when
electronics.
your telephone gets hot, I suppose.
That's exactly right. So the way that technology is moving now is that the power density of batteries and electronics generally are becoming more powerful and smaller, which means that the thermal management of those systems now is driving towards liquid-cooled systems rather than what might have previously been air-cooled alike. So you need now more efficient cooling and liquid-cooled systems, and that's PWR's next journey is, and we're building on that now as defence and aerospace.
So Phil, I'm getting with the place. This is a bit more than automotive. this is getting pretty high tech.
Yep.
Far out. No, that's impressive. It's clean, dude.
Yeah, so I'll just a couple of examples of the types of components and I guess the supporting assemblies that are around them.
Yep.
This is a little cartridge style cooler, so one of these compact heat exchangers which use lots of very, very fine tubes. In this particular instance, you'd have water passing through the tube and an oil passing over this external side. So
Gotcha.
That little cartridge.
So two fluids.
That little cartridge.
Water internally and the oil.
And oil over the outside.
Yeah.
In what sort of instance? This is.
That particular one is a little aerospace application, like a drone.
Is that right?
Yeah, absolutely.
That's your housing for it?
That's the housing, yeah. So that, that little thing there drops in like so, and then it's capped off.
Put it in
directly bolts, away you go. So you've got one fluid going this way, one fluid going the other way, and this particular housing has also got little tuning ports either side that allows a little bit of bypass on either fluid just to be able to get that. Yeah.
And you make the housing. So
we make the housings, do everything in-house. So the heat exchangers.
Look at that. I just can't get over how fine. I don't know if you can see. I don't know if this is going to work though. Can you see how fine that is? It's like honeycomb, but on steroids, small. Like, and that's the tubes on the side. It's insane. I can't even see through it. It's that fine. Oh, you can just. It's just amazing.
Yeah.
You can see what you see about particles and you get that fine.
Absolutely, it's really.
And you can go smaller than that.
We can go smaller.
But we can't see that.
No, that's right.
Oh, is that automotive?
Automotive, and again, and defence and aerospace is a big opportunity for this company as well. But yes, there's a lot of automotive application as well. Anywhere that requires compact, where you want to be lightweight and you want to be very, very condensed the size of the final assembly, there's an application for this type of.
Tour's getting better.
Right.
What else you got? You can't get better than this,
can you? You could hide a lot of that stuff. I don't even know you had it if you were racing, couldn't you?
Yeah.
How would they ever find it?
What are you saying, dude?
Just saying.
Just saying. All right, Matthew. This is getting better.
Come on through, guys.
And what do we got here, Matthew?
So this department is our vacuum brazing, heat treatment and anodizing plant, and this particular department is integral to our advancement in pretty much electrification within motorsport and automotive, but also aerospace and defence. This department will almost certainly be dominated by aerospace and defence applications going forward, and has some highly specialised processes to manufacture componentry that's just simply not manufacturable by any other means.
That looks like an autoclave, like a carbon fibre autoclave.
Correct. So it shares a lot of similarities in terms of its operation. It is operating under vacuum, just as an autoclave will. Right. But in this instance, it's brazing high strength aluminium for some of these specialised processes.
Oh, okay.
And then after brazing, we're then doing a solution heat treatment to ensure that it gets back to its original strength of the intended alloy. So it's all
taking two sheets of alloy together that you machined, brazing them together.
That's correct. So to give you a little bit of an explanation, we've got a couple of parts over here. So what it enables us to do is to create some quite detailed internals inside of machined components that otherwise wouldn't be possible. So here you can see a cavity that's been machined into this block. That's it. So we've got machine detail there. And then the process would be that we would load a piece of brazing foil over the top of there. So that is a lower melting point aluminium than the parent aluminium block here. And then we'll close that in with another machined piece of aluminium. And that will then get loaded into the vacuum furnace. It gets brought up to the temperature that the brazing foil in between those two blocks, the melting point of that, and then it's cooled and you've got one solidified aluminium block. It's now one block, but it's now got an internal void that would have otherwise been impossible to be able to produce. And so
you've got to cool it.
That's right. So then we do a final machining operation around the outside with respect to the detail that's already inside the block.
And then through your hardening process, re-harden the alloy again, and then you do your own anodizing.
We do our own anodizing.
Now, Keith said to me that this was actually a project for some of your young apprentices to
Correct.
actually, because they don't make an automised
They definitely do not.
anodised.
So this is something that we set up for ourselves to meet a NADCAP standard, which is effectively a particular quality standard that's required in aerospace and defence for anodising. So the processes that anodising requires are shared processes in regards to a lot of the cleaning processes that are required to treat these aluminium components before they're vacuum brazed. So it's helping us with the material preparation before brazing, and then it also allows us to do a final anodising process of the finished part after it's been through all of the machining operations.
So the good thing about it, like, dude, and what we've seen here, a lot of this has been developed internally, in-house.
The use doesn't exist anywhere else in the world. You break a new ground every time you do something.
So
it's amazing.
That's what's blown me out about the whole tour, Matthew, is that, you know, you sort of look at all this and it's not only the parts that you're manufacturing, it's the machinery that you've pretty well had to come up with yourself to manufacture the component.
Correct.
You've had to manufacture the machinery.
So it's specialised equipment that we've either designed and manufactured for ourselves, but it's also about that vertical integration. So we don't rely on subcontractors for any of the work that we do. It gives us control of the quality of our product, but most importantly, it gives us control of the lead times that we can operate in. And particularly, as you boys would know in motorsport, a week's a long time. And if there's a better idea, everyone wants it the moment that they've thought of it. And that's been something that PWR has been highly successful in delivering, and that's because we own all of our own processes.
That's incredible. And it's like the Larry Perkins, Stone Brothers Racing, and even you when you run a team to do as much as you can in-house, because you've got control of your destiny, you know?
That's right.
Oh yeah, it's pretty, and all that's timed as well, is it? So
that's part of meeting the NADCAP standard, is to ensure that your components are only exposed to each of those processes for a very specific amount of time.
Right.
So automating it was actually the easiest way of us being able to guarantee that you're able to meet that standard every time.
Because otherwise they just hand dip it, don't they?
Correct.
Usually with anodising.
Correct.
No way. Incredible. And that's what I like. I like that apprentices have made this machine, designed it, and was given a project, and they come out with something very unique, you know. So, oh, that's cool. Have you got anything better than this?
I better hand over to Keith to show you the rest of the show. I reckon.
Yeah, okay, all right. You've had enough of us, haven't you? All right.
No worries.
I appreciate it. Thanks, Matthew.
Pleasure.
It's been very interesting. There he is.
He's still on the tour, mate. Hands on.
YouTube.
There's a boss himself.
YouTube channel.
Hey, Keith.
Hey, Rusty, you're back again, mate.
Yeah.
That was touring.
Mate, Matthew was great. Showed us
Good. Did you get the technical side? Did you get the technical side?
Stuff we're allowed to see.
Oh, okay.
Pretty incredible. No, he was pretty open book. It was, mate, mind-blowing.
Yeah, no, he's
Mind-blowing. We were just walking around with our mouths open the whole time going, how good's this? But
Well, that's sort of the next level in the future. You know, when you start talking about aerospace and defence, that side of the business. The world's just, it's an arms race. Across the world, it's just an arms race. Everybody's just, you know, border protection, all this sort of stuff, trying to make things lighter, smaller, more efficient, blah, 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 all that sort of thing. It's and the good part about it, it's exciting. Yeah, it just
Yeah, it is exciting, isn't it?
Yeah, well, even for us blokes, you know, we're a bit old. These young blokes, you know, employ a lot of engineers and what have you. Those young blokes love that stuff. For us blokes to be involved in it and taken along for the journey, that's what wakes you up early in the morning. You know, because you're thinking about stuff and say, well, shit, how good's this? Or what can we do there? And you know, you're making stuff for Boeing, or you're making stuff for, you know, electric lift vehicles and all this sort of stuff.
it's amazing.
It's the next generation.
we can see it in their faces too, Keith. So they're really interested in it. It looks like every time they come to work, it'll be a new journey.
Yeah. Everybody's happy here, mate. So they should be, but everybody's happy.
You can see that, the culture and the whole place is very inspiring,
But
That's good.
leads us to here. This is where it all started. This is the grassroots
This
side
sort of
the
the
business.
grassroots, and you know, when we're having our coffee this morning, we're talking about different things and what have you. And I said, you know, don't forget where you come from. Don't forget where you come from, and that's where we are right now. This is where we started production like this. it's grown a lot over the years and got more finesse with it and what have you. But this is really the grassroots stuff for, you know, when a person comes in with a hot rod or an off-road car or someone four-wheel drive, someone towing a van or whatever, say, hey, listen, I'm going away, I don't want to be stuck on the side of the road, can you give us an upgrade with this and put an oil cool on that and blah, blah, blah.
Can we have a look?
Yeah.
Take us through?
Okay, yeah, well, let's have a walk through and what have you. So this is just normal stuff, just normal stuff we do. Starts off with fin machines, because we make, as we said before, we make everything in-house, and that's the that's the fin material there. So it starts starts off, goes through the machine like that, comes through, comes out like that, and obviously we have I don't know.
So this is made right here.
Yeah, 14, 15 fin machines for different variants, and everything we do is made here. On site, we don't get anything in, nothing gets in a box and we rebrand it. There's none of that stuff.
Yep.
This is 100%
Right
Australian
from the cooling
made.
fins, cooling tubes, tanks.
The whole 9 yards. It's a routine here, like stacking cores. These guys are putting headers on through our furnace and washing oven there and going straight into our furnace. Everything's assembly line. Yeah, it's an assembly line.
All the process all the way through.
Yeah. So we've got core manufacturing on this side.
Yep.
And then we got sheet metal on that side there.
Yep.
And it all marries up. We started making these in 2000.
This wasn't the Bridge and Stratton one, was it?
Yeah, that's it.
It was?
Yeah,
I remember that story. It was a good deal. I remember you told me that deal.
Yeah, we're sending containers to the States with these, and they're making these lawnmowers over there, and they're 2 per lawnmower.
Lawnmower?
The Bridge and Stratton, wasn't it?
Yeah. And those ones there, well, that was, I know you've been speaking to Matthew, this is one of his first jobs when he arrived in 2000 or 2001. And he designed all that, done all the design work and that. So we manufacture the tubes, the fin, just everything we manufacture in-house here.
Yep.
And I think we have sold nearly 2 million of these in 20 years.
2 million?
It
Keeps
is,
the lights on,
it
eh?
is, it does. I call it the cookie cruncher thing.
Yeah.
Keeps the lights on. Yes, we don't make a lot of money out of it, but it's a cookie cruncher thing. It keeps the furnace going. It pays. Well, it sort of pays for the power for the furnace, and the rest is
So the American guy sitting on his lawnmower, cutting his lawn on Sunday, drinking his beer.
Yeah,
He's got an Aussie cooler on his mouth.
that's it. That's it.
Amazing, isn't it?
So,
who would have thought?
Yeah. So, and we do things like Herod's doing that job down in Melbourne for the Scotty McLaughlin thing. Yeah, the McLaughlin thing. I just noticed that because that's
he's made a transmission cooler for that too, hasn't he?
So that's
Scotty McLaughlin
Herod's,
17,
Scotty McLaughlin 17.
And that's on the radiator?
That's on the radiator. We also done the ones for the DJR ones.
Yeah.
The Dick Johnson special, or what they have last year or the year before down at Bathurst. They released that.
Right, what's next?
Oh, well, let's go to the machine shop.
Okay.
And we'll go from there.
Yep.
Well, here we are. This is the machine shop.
What predominantly do they make?
Well, the big thing today is header tanks.
Tanks.
So all the way out of billet, which I know a lot of people wouldn't understand what that is, but I'll show you something in a minute. What have you, just give people a bit of an idea back home when they're watching of what actually goes on here. I get people in here and you think, holy shit, these guys, why do they want to build a tank? Because they can. That's bullshit. I know.
It's mobile jewellery.
Yeah, that's it. So that sort of gives you a bit of an idea. I know it's a very small billet tank. You can see how it's got. Obviously, it's made out of a whole piece of billet, but you can see how it's got a little piece left in there for it to stop.
Give it some strength.
Well, it stops it from panting. They call it panting, and then when it pants, it cracks, and what have you. So that's that there, and then you got that's your finished article. That gives you a bit more of an idea of what that is. But we go to that, then you go to extreme little things like that. That
Look at that, eh?
like being a part number in there,
Yeah.
all that sort of stuff. So yeah, as you say, it's fucking jewellery. it's jewellery. And then you go to the other side of things, which is a bit bigger, and you got a tank like that.
Yeah.
Part of the tank, and just milled out of a solid piece of material. So that's a big part of our business now. There's not many categories around the world that don't have billet tanks. You look at WRC, for instance, like those guys are racing rally, and they'll change radios and coolers every
Service park if they can.
couple of hundred Ks, and they just put them in the bin and
ordering a new one.
and order a new one. I say why, and they say because we can. And I said, how are you going to argue with that? You can't argue with that. You know, like that's a radiator. It's out there. It is.
See that one?
It is out there.
Yeah.
No, it's for Honda. Honda Moto GP bike.
Oh, it's a Moto GP bike radiator, eh? Oh, you can see that when you see the Moto. You can see it in the front.
You can see it on the front of the GP
That's
bike.
why
It's got our logo on it. It's down this side here, Rusty. Everything's jigged.
Yep.
This is for a F1 customer, if you like, and that races red cars. So everybody worked that out. So we make sure the one we make today is exactly the one that we make on the last race of the year.
Now I know you got something here, Keys, I'm really interested in. You got a bloody big hairdryer here. Not too many people have seen it. Can we have a look? Come on.
If it's here, let's have a look at it. Yeah, this is certainly a little bit different. Not as you say, not many people get up here.
So explain it in briefly, in layman's terms. It's a wind tunnel.
It's a wind tunnel. Wind tunnel just to test radiators, intercoolers, oil coolers, what have you. So, what all this? I know this looks elaborate, and it is, but what it does from that end to this end here, it conditions the air. So the air that's going to go through a product to test, that conditions that air. So when the air comes down the other end there where we're testing the product, anywhere in that meter area, you got the right temperature, you got the right pressure, and all that sort of thing is anywhere in that meter area is controllable. So you can put a cooler in there. We have thermal cameras inside the end there as well, so it can see how the cooler's heating up as we put oil or water through there. So it's just like a car.
It's a dyno for a cooler.
Yeah, that's right. Yeah,
But it sort of looks like, correct me if I'm wrong, but it looks like a chamber of a two-stroke exhaust pipe. You know how it goes in and out? Is that because you're changing the airflow as
that's
it comes
right.
through?
The turbine's right down the other end, so it's sucking air outside the building, bringing it in.
Yeah.
And then it's pushing it through these areas here. And in there, we've got a 2.5 metre square radiator that actually heats up the air. So everything we test here is tested at 40 degrees C. So air temperature is at 40 degrees. And 40 degrees C is that sort of number that they talk about. Well, that's the ultimate. You know what I mean? So if you're going to be racing at Darwin or Saudi or this or that, or doing the Dakar or whatever, you know, that's so your product's being tested at that level.
So where's it mounted? Where do you mount the product?
Come through. So basically, that's a 300 square piece. We do a lot of testing for our own testing, for development testing.
Yeah.
So we start off with 300 square. So we've always got a data bank to go back to.
So you want to try different fin configurations?
Correct. Different fin, different tube, different angle fin louvers, etc., all that sort of internal stuff.
You got fluid running through it as well.
That's right.
So it's just not the fins.
It's in and out.
That's correct. It's in and out. The fluid is like a car. So what you're doing is replicating a car cooler in a car. So you got hot water in, cool water out.
So you're checking how efficiently it cools as well.
That's right.
As well as how much restriction the air is, like the whole.
Also the air pressure drop across the cooler. So you look at different categories around the world. You look at an F1 car.
High speed.
Yeah, high speed. F1 car wants the least amount of air going through the cooler and the most amount of air going over the car. Keep the car on the ground, in layman's terms. And very similar to NASCAR.
NASCAR want the downforce.
Yeah, NASCAR need the downforce, so they don't want a lot of air going through the cooler. They want to cram it into that front duct, so it's downforce.
Pushes it down.
And that's why when you hear the stories about tape, they put tape on the radiator.
Oh yeah.
So if they want a bit less downforce, they take tape off. If they want more downforce, they put tape on. I know that sounds crazy,
No.
in our world,
That makes sense.
it is very simple.
We used to do it in the form of fluids.
Yeah. How'd you go with that?
No, I did it for temperature, but it might have actually been given a downforce. I didn't even know.
We've had a complete front of a NASCAR here.
Yeah.
We've had a complete front of an earlier model supercar.
Yeah.
Not the current model, but an earlier model with a team that wanted to have it here and go through the whole tunnel thing. And F1 teams are usually out here about October, November, and they'll bring a whole half of the car out, and as in
So the radiator's sitting in the pod.
Yeah, so
bring that piece, eh?
yeah, so they have one half of the car. So all the radiators are lined up there. So you'll have an intercooler, oil cooler, water cooler, probably a low temp cooler for the batteries and the electronics. So you've got 4 to 5 coolers all in situ, and we can test every one of them with all the loops we have. We have all the loops there ready to go. So yeah, it's a bit of the magic when you're coming out. There's pipes and hoses and leads going everywhere, but they come out and they are dead set serious. They'll be here for 3 days and they'll have 5 to 6 hours sleep over the 3 days, just getting the most out of that. But this here runs every day. If we're doing customer stuff, we do customer. If we aren't doing customer stuff, we're doing our own R&D.
Only one in the world, Keith?
Only one in the world like this.
No, it's massive. I can't believe the scope of it. It's amazing.
And if you're buying a cooler for your Ranger or your Land Cruiser, it's not going to let you down because you've tested it.
It's been through here. That's right.
Keith, thank you very much.
Thanks, Rusty.
It's been an eye-opener,
No worries.
to say the least.
That's been good.
Very
Keith.
cool.
Good on you, Paul.
Very
Thank you.
inspirational stuff, mate.
That's really
It's
good.
a credit to yourself and Paul. I mean, starting this up
Yeah.
from basically from scratch, and it's a giant, and just space is the is it?
Next level.
Yeah,
Good, isn't
yeah,
it?
no, that's right.
And
Up to the
build
next
on the back of going motor racing. That's what we love about it.
Yeah, yeah.
It's awesome.
Well, that's what I mean. That's what I said in there. Don't forget where you come from.
Yeah.
And we love it.
Absolutely.
Grassroots racing is still part of us. Off-road racing, all that sort of stuff. We love that. And but it's also good to see new technology come in to any business. That hey, we're employing people. That's what we do. Employ people.
For sure, and a lot of them.
Yeah, a few.
Thanks, dude.
All right.
See you,
Thanks,
mate.
guys.
See you,
Take
buddy.
care. Cheers.
Well, it's an eye-opener, dude. Like, you walk through this sort of place and it sort of makes you proud to be involved in the automotive and motorsport industry like we both have.
Yeah.
And you come to places like this and, like I said, people like Keys and Paula that started it from nothing, and they're racers, we were racing all together.
With Paul,
Paul was a good steerer.
in Darwin.
Yeah,
He's racing in Darwin.
He still is, yeah. But it's just a real great success story, and as I always bang on about, it's a bit like the automotive industry. We've built some of the best cars in the world, unfortunately at the wrong time, with Ford and Holden. But industries like this have just kept growing, and not many people know about them.
Well,
That's why we
it was
really
good
want to do
down
the
here. It was
show.
a good one, Russ. Good idea, mate.
Yeah, no, it's just, mate, it's good. You know yourself, you like helping out the underdogs. I mean, by no means is it an underdog, but geez, it's a great story.
Yeah, it's a bit of hard work in there.
Yeah, I mean,
He's still got his hand on the tiller too, you know, Keys. That's why the place is good. So,
well, yeah, it's a world-class product that no one else makes, that the biggest motorsport and automotive industries in the world are using their product. And from what I'm looking around, I'm getting a picture here, as Keys alluded to, Defence Force. You know, there's the technology, aerospace, yeah.
electrification.
That's the one. That's the one I'm seeing when I'm looking around here, because everything has to be cooled, doesn't it?
It does. The computer power generates heat, so they've got to cool it off. So yeah, they're ahead of the game.
Massively. So it's been really interesting. I hope everyone out there has found it interesting. That's why we wanted to bring you this sort of thing, and that's why the inception of the show, Forster and the Dude, was always about showing you stuff that you don't normally see, because somehow we get the keys to it, we get the access pass, so we can bring it to you. Make sure you subscribe to our YouTube channel, Forster and the Dude Facebook as well, so you get notifications when shows hit, like this one. You're the first ones off the rank to grab them. And if you've got any ideas on places that you'd like to see, send them in your comments.
Yeah, we don't know it all, so send us on a journey.
Dude's Life message. We got time for that, and that's about it, because this one's been a marathon.
I've got one, mate. It's a good one, and I've been inspired as I've been walking around here.
Yep.
And it's, let's all work together to make the world a cooler place.
And here we are in advanced cooling technologies.
Fantastic, isn't it?
Yeah, it's a good one. Well, all right, let's get out of here. After being through that clean room, can we go clean your truck?
You can wash my truck for me, mate.
Your truck's a dog, seriously, dude.